Okay, so in this video, let's understand what bagging is all about. So we saw in the previous video that there are lots of ensemble techniques, but bagging is one of them, and I'm going to discuss bagging. So look, a very popular model. So wait, what bagging basically does is that it uses sampling with replacement to build your models. Okay, uses sampling with replacement to build models. All right. Now, let me just take an example. Let's say I have a data set dn and I have the data points xi, yi, where y is the class label that I have to predict. So what I'm going to do is I'm going to sample. Let's say there are m points. I'm going to sample n points where obviously n is less than equal to m, right? And now the important thing to note here is that this is sampling with replacement, meaning I take a point. So let's say I sample and I get a data set dn1, right? So this is sampling with replacement, meaning that I take a point, I put it here, then I put it back into dn, and that point is available again for, it can be, there's a small possibility that it will come again in my data set dn. Okay, so let's say I have dn1, then again I do it again. I sample with replacement some n data points and I get dn2. I keep doing this until I get some dnk, right? So since I have all of these data sets of size n, where n is less than m is the total number of data points in the actual data set dn. Now what I'm going to do is I'm going to build a model on this. Model 1, model 2, all the way to model k, right? So look, one of the most popular models of bagging is called a random forest, which I'll discuss in detail in the next video. So once I have all these models, what I'll do is, this was called, so I've sampled everything over here. And once I have all of these models, I'm going to combine all of them, the results from all of them, to make a bigger model. And this is called aggregating. All right. The combining the results of all these small base models to form a bigger model is called aggregating. Okay. So let me just recapitulate some important points. There's a small probability that the same data point occurs again in the sample. Because we are sampling with replacement, right? So there's a small possibility that you'll see the same data point twice or thrice in the same data set, in the same sample of a data set. So look, it's important to understand here that each model MI, M1, M2, all the way to MK has seen a different subset of data, right? And then you combine all the models to a final model M, okay? This combining of all the models to a final model M is called aggregating. So there are lots of techniques for aggregating. So if you have, let's say, a classification problem, aggregating might be taking the majority vote, right? Majority vote in classification. So let's say M1 says 1, M2 says 1, class 1, M3 says class 1, M4 says class 0, and so on and so forth. This bigger model will aggregate to take the majority vote of all of these classifiers, all the base models, and the output will be whatever class gets the highest number of, like whatever class is the highest in all of these models, right? So in the setting of regression, if it's a regression problem that you're trying to solve, you can probably take something like the mean or median, right, in your aggregation stage. Okay, so that's how classification and regression would differ. So how does this model work? I get a query at runtime, and at runtime, I send that query to each one of these models. Okay, all of these models, they analyze the query, they give me an output for my class label, and whatever's the majority class label that I get from all these models, that's my actual class label for this model, for this big model M, the aggregating model, right? So that's how this works. Now, one of the most important things to understand in Bootstrap aggregating or bagging is that bagging reduces variance. Okay, bagging reduces variance. This variance is the variance from bias and variance trade-off. Okay, what is variance? Just to recapitulate, variance is basically a small change in my data set causes a large change in the output of a model, right? Small change in data set causes a large change in the output of my model, correct? So variance is basically the error that you get. Variance is basically the error that you get from a model. If you remember carefully, the model error can be defined as variance plus bias square plus some random error. So variance basically it means overfitting. It relates to overfitting. If you don't know this, you can just watch my video on the bias variance trade-off. I've covered all of this there. So it's important to note that bagging reduces variance. How does it do that? Look, if my actual data set dn changes a little, right, the change will not be translated to all of these models. It'll be translated to some of these models because I've taken a sample of the data set from my original model dn into all of these models, dn1, dn2, all the way to dnk. I've taken only a sample of the data points. So when I change my original data set dn a little, not all of these data sets, data set subsets get affected. A few of them do, but if I have a large number of models over here, not all of them will get affected. So my output from all of these models remains unaffected to a large extent. All right. So the variance is low in bagging without impacting the bias. That's the point I want to drive home over here. The variance is low in bagging without affecting bias. Okay, this is the main point to drive home from all of this explanation that I just said, right? The overall model doesn't change much. So basically, the base models might have, they'll have low bias and high variance. Okay, these are the base models that I have in my bagging model, Bootstrap, that I have in Bootstrap aggregating. But the combined model bagging, it has low bias and it has reduced variance. Okay, so if you remember carefully, one model that has low bias and very high variance is a decision tree. A decision tree of large depth has a low bias and a high variance. And to overcome that problem, we use bagging. And the synonymous model to decision tree that we use with bagging is called a random forest, which I will explain in the next video.